Welcome back to Networking Basics. In this section, we're going to be talking about networking essentials and basic topics that belong to networking, as well as standards and how these standards are used to develop ways in which to agree about communication between machines. We have standards bodies that come together to work on these issues because computing is such a worldwide phenomenon and it belongs to the working world and to society itself. So we have to have standards organizations that will make decisions about the best way to handle networking issues and to ask the right questions and come up with the right answers to engineer and put together the ways in which we will communicate using these physical devices. We're going to also get into the logical nature behind it as well. There is a bit of logic to how devices are networked and how they are brought together to communicate. So there are a lot of topics here. We will look at networking basics and standards. We will also look at networking terminology in brief. You can read these and study these on your own to learn them. And also the OSI reference model will be discussed, as well as the 802 standards, 802.x standards created by the IEEE. And then also we'll mention NDIS and ODI at the end. So again, the concept of networking is going to be expanded here to include many additional aspects that show the logical side of how machines are connected together in the physical way that they are. So keep in mind that we will be going through a lot of details in how this is supposed to come together. Now you know about LANs, MANs, and WANs, and also PANs. You know what a local area network is. You also know what a metropolitan area network is. And these are network subnets and domains that are connected across cities. It might be down the street a few miles, or it might be clear across the other side of the city. And then you know that we have WANs, which are wide area networks, that are long distance networks that are connected over long distance WAN links. And that in itself is a specialty in many ways, with optical carrier networking involved, as well as other kinds of technology like ATM and frame relay and sonnet rings and other types of technologies as well. Then you have PANs, and PANs are quite ubiquitous today because people have so many of these personal devices like PDAs and cell phones that are really smart computers and iPads and other types of PC tablets and so forth. And so we have these multi-connected devices that can talk to each other in very small area networks. And one of the great technologies here is Bluetooth. And when you have a Bluetooth PAN, you have what's called a PicoNet. So these are wireless. They a lot of times you see a lot of USB connections and FireWire connections, and you can you see this in coffee shops as well as with business people who are on the road selling and developing their market. So it's out there, it's everywhere. Now there are quite a few terms that you need to come to grips with, and you'll see that they're listed in alphabetical order. You need to read these, study these, and start with administrator, authentication, centralized processing, which is mainframe computing, and right on through client, network operating systems, nodes, protocols, server, sharing, transmission media, and of course workstations. These are at a minimum the types of computing terms that you need to be aware of and you need to use and be fluent in. The OSI reference model is the next subject in this topic area. And this is a model that was created by the ISO in 1977. And what it does is it promotes a way in which network architectures can be in a modular form, and we can all agree on how to do this so that our machines are multi-platform and they can reach across many types of networks, and there be a little less competition than there could be for market share, because these companies could come to dominate the marketplace and could force their way of doing things on other ways of doing things. And so we need to keep everybody playing on the same field. And so this is why they do this, is they want to insist that network communication is handled in a reasonable way. So you have these seven layers, excuse me, I started to say nine, these seven layers that are in a hierarchical model. They start with the physical layer at the bottom. And the physical layer is where all of your wiring takes place. And most of your networking problems are going to be in the physical layer. The physical layer it has the different types of wiring standards, like category 5 and category 5E cabling, copper wire. You have your fiber optics here as well. All of your WAN technologies are at this level too, by the way. When you look on a network communications chart, you'll see that they are listed and mapped to this layer. We have analog and broadband and signaling technologies that you're used to. They come in at this layer 2. In fact, if you'll remember the modem days, where the modem was an independent device outside of your computer, and you could demodulate and modulate the analog signals into digital signals, and this way you could talk to an internet service provider and the servers there that would enable you to connect into the internet. So you'll want to get familiar with this area. You don't have to be an electronics expert. You do need to know that here your zeros and ones, your bit synchronization takes place. This is the bit stream that comes into your computer. And so at the very, very basic level, we have base 2 and we have binary. We have zeros and ones. And these are what are coming across the wiring into the machine. The next layer up is the data link layer. The data link layer, the most important piece here is to realize it's in two pieces. It's two layers, the MAC layer and the logical link layer. And the MAC layer is where the MAC address is, the hardwired address that's in hexadecimal form at the factory, and it stands for Media Access Control. And this is the address that is hardwired into the NIC, the NIC card, the network interface card, that's in the back of your computer, where the Ethernet broadband connection is established in your machine. This is something that is important to understand. Again, it sounds technical, but you don't have to be an engineer here. You just have to understand that this is what this area is about. There is issues to do with error control here. The data link layer is divided by the 802 standards here into the two sublayers that I mentioned. And you'll find that this layer kind of hands off it's starting to take the bits and put it into the form of a packet. And so it hands off the packets right on up the layer to the next layer. Like the next layer is the network layer, and this layer here is now responsible for IP addressing, where we've got to find out where to send everything. And the network layer uses a protocol called the IP protocol, the Internet Protocol, and it is able to read and look at the IP addressing that's in IP version 4 currently, is soon to be changed over into IP version 6, or at least have dual translation involved in that. And there's a lot to that. It's beyond the scope of this course. But the network layer headers define a logical address. And this layer will translate between the physical MAC and logical network addresses so that everything gets forwarded to the right place. It needs to go to a certain subnet, or it needs to go to a certain network segment, and it knows by looking at the address how to send it. Now we'll get into addressing later, but just to tip you off a little bit, addressing has to do with separating the network ID from the host ID. And so a part of the address is masked in such a way that the computer knows that this portion of the address belongs to the network ID, or the net ID portion, and the rest of the address belongs to the particular machine. And that is yet to come as we look at network addressing and IP addressing. Above the network layer is the transport layer. And here we have the two most important protocols that we have that we're going to talk about, and that's the TCP protocol and the UDP protocol. And the TCP protocol is at work here in the transport layer. The thing about the TCP protocol is that it has to have a connection established first, and we will talk about that when we get to the TCP IP suite of protocols. Above that layer is the session layer, and it maintains a session. That's what it does. It establishes the virtual connection, and that way the computers can send periodic messages, and it can maintain the connection and keeping it established until everything can be finished. And this is its responsibilities. There's name resolution and security involved here in the session layer as well. Then above that is the presentation layer. The presentation layer is a layer that literally presents the rest of the packet, so to speak, to the application layer above that. So this is a layer that gets involved in encryption and decryption, for example. It uses compression sometimes. The presentation layer is handled in Windows NT, by the network redirector, a software driver that allows applications network files and printers in the same manner as local files and printers do. So that's the presentation layer. And then we finally have the application layer, and this is the layer that you and I are the most familiar with in what we do in our daily lives. This is where all the applications are. It controls access to these applications, and one of the most common ones that you're familiar with, just to give you tip you off a little bit, is HTTP, which you see at the beginning of all of those URL addresses in your browser. You see HTTP, and that's a protocol, and that protocol is mapped to the application layer in the OSI model. So it's a big model, and it has these 7 layers. And the way to remember the 7 layers is to say to yourself, all people seem to need data processing. All people seem to need data processing. And that'll help you to remember it, because you can say application, presentation, session, transport, network, data link, and then physical. By remembering that little sentence there. It's a mnemonic, and it will help you to memorize those layers and keep them in your memory as you do your work. Networking Basics also includes a discussion of the 802.x standards, and you'll see that there are a lot of these. They run from 802.1 all the way in the list that I have to 802.23. These standards we could talk about for the next hour. But basically, what you want to do is read through them and get an idea about what each standard is talking about, what it is dealing with. Like 802.5 is token ring, for example. And then you'll get an idea of what that standard is about and what it refers to. You hardly ever see a token ring network anymore, even though they are certainly out there. You'll see that the 802.11 standards are mentioned, which is what you're familiar with your Wi-Fi networks. And you'll see the 802.16 standards, which are the ones that refer to WiMAX. So there's a lot there on that page. Don't get overwhelmed by what you see. Just become aware of it and get a grasp of what is there in front of you. Finally, I want to mention NDIS and ODI. NDIS is Network Device Interface Specification. It's a standard developed by Microsoft and IBM to define communications between protocols and network card drivers. And the purpose of NDIS is to abstract the functions of the network drivers so that the protocol can work with any driver. That's an improvement. The current version is 4.0, and you'll read about that. It has a process used that's called binding, and binding is what's going on when we get these network cards to cooperate with these protocols. And Microsoft is just doing what it should do. It creates a service to keep things flowing properly when their protocols and their applications are involved. ODI is Open Data Link Interface. It was developed by Novell and Apple. It's an implementation of the same functionality, and it was primarily designed for the IPX protocol. ODI can be used with any protocol. So even though IPX is not that prevalent anymore, and Microsoft is really very dominant, then we still have functionality between these devices because they've developed these smaller protocols that will enable this communication to go on. So I hope that gives you some idea of what we're talking about here with the OSI and the 802.x standards. We will be looking at the TCP/IP model. I have a special lecture probably on that.